guys, welcome to another video of 7A Math, and for this top video we're going over 4.4 least common multiples. Okay, so a lot of people will mistake this one with greatest common factor. In fact, I had students already turning least common multiples instead of doing greatest common factor. However, as you can see, they are quite different. So first of all, what are least common multiple? Well, let's break it down. Let's talk about multiples first. Well, multiple is a number when we multiply it by another number, such as multiplying 1, 2, 3, 4, 5, etc., but not 0. It's like a multiplication table. Okay? Think of least common multiple as multiplication table. What do I mean by that? Well, find the multiples of 3 and 5. The multiples of 3 are 3, 6, 9, 12, 15, 24, 27, 30, and so forth and so forth. Multiples of 5 are 5, 10, 15, 20, 25, 30, 35, 40. Kind of get it. That multiplication table. So, but unlike the main difference between factors and multiples are that factors are finite. There's limited amount of factors of a number can have, but a number can have infinitely many multiples. So think of multiplication table when we're talking about multiples. Ooh. Let me change that one, my highlighter. So factors are this one. Think of factors as this and the number right here. Those are your factors. Your multiples are those inside. So the multiples of 2 will be this. Multiples of 5 will be this. You can see it, right? And as you can see, if you think about it, multiples can extend infinitely, but the factors cannot. There's a set amount of number that can only multiply. If you multiply them, you'll get that number. That's why when we do factors, like factors of 12, this is factors. You can start with 1 and 12, and all the factors of 12 will be inside of that group. There's limited of them. However, for multiples, we're just multiplying 12 times some number, a variable. It can be 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, and so forth and so forth. It can be 1 billion, and 12 times 1 billion is the multiple of 12. 12 billion. Okay? Hopefully that clears up the difference between multiples and factors. So, since multiples can be infinitely many. Oh wait, I'm going ahead first. So what are common multiples that is shared by 2 or more numbers? It's like common factor. The multiple that appears on both numbers are common multiples. So here, 20 is a multiple of 4 and 5. 40 is also a multiple of 4 and 5. You can think of more. If you extend this one, you'll get 60 and 60 here, and 80 and 80. Things like that, so forth and so forth. And as you can see, can we ever find the biggest common multiple? Can we find the GCM or whatever, if there's such thing? No, because since there's infinite many here and there's infinitely many here, infinitely many multiples of 4 and infinitely many multiples of 5, you can have infinitely many common multiples. you might think you already have the highest common multiple, but in fact, there's a bigger number than that, because there's a fundamental thing in math that's there's there's such thing as an infinite numbers. Okay, there's infinity. You can go forward and so forth and so forth until you reach infinite in math. So there's no such thing as greatest common multiple. So instead of going greatest, what we're going to do is we're going to look for the smallest common multiple, or in this case, least common multiple. Again, least or smallest, they're basically the same thing. Smallest, you can find any acronym, not acronym, any synonym for that least word, and a still word. So again, it's the least smallest of the common multiples. So here, previous example, which one is your least common multiple? Is 80 your least common multiple? No, it's 20. It's the smallest one, it's the first one that appears. So how do we find LCM? So there's two ways. The first way is you list multiples. Like listing common factors, here we list multiples. But instead of listing one multiple, more than one multiple, we're only going to list the multiple of one number, and that number is the largest number. Okay? We're going to look. First step is look for the largest number, find the multiple of that number, that large number, and then the first multiple that all other numbers divide is the LCM. And as you can see, this is why I want you guys to use your calculators, because these multiples are already too hard enough, and later on we'll do it with fraction, which makes it double hard. So to have your answers correct, use your calculators to double check, but I still need you guys to do the steps so I can see that you guys are actually doing the least common multiple. And then there's another step. This is the prime factorization. Again, keep telling you guys, prime factorization is your tool for math. It's one of the tools that the earliest tools that you can learn, and it will help you in fractions a lot. And here's another way to use prime factorization in fraction, finding the least common multiple. So first of all, we're going to list the prime factorization of each number, and then we're going to multiply each factor, the greatest number of times it occur in either number. So it looks tricky for step 2, but later on we'll see that it's basically the same thing. This one is basically easy. Sounds hard, sounds complicated, but it's easy. And you can click on this YouTube link to give you a video on the difference between using prime factorization when you find GCF and using prime factorization when you use it to find the LCM. Okay, here's a good link. You can click on that on your free time, but right now I don't want to get copyright, so we'll skip that. So we're finding LCM of 16 and 24. So for step 1, which one is the bigger number? 24. So 16 is bigger than 24. 24 is bigger than 24. So what we're going to do is we're going to find multiples of 24. So start with 24. Can 16 go to 24 and have no remainder? No. So how about 48? Can 16 go to 48? Let's check your calculators. Yes. So your LCM is 48. And that's it. You just pick the multiples of 24 and then find the multiples, thinking each one of them, can 16 divide this number, yada yada yada. And the first number that 16 can divide is your LCM. In this case, 48. Let's try method 2. So prime factorization. of both numbers. Let's do the factor tree. We'll do it here. 16, 2 and 8, 2 and 4, 2 and 2. So 16 is 2 times 2 times 2 times 2. And 24 is 2 times 12, 2 times 6, and 2 times 0. So basically 2 times 2 times 2 times 3. Now, it kind of will look similar to finding the greatest common factor using prime factorization. However, there's a key difference between the both of them. Let's use a highlighter. This 2 appears on both, 2 appears on both, this 2 appears on both. So what we're going to do is we're just going to multiply all the numbers. Okay, I don't know how to explain it, but you're going to multiply all the numbers. So this group represents this 2, this group represents this 2, and this group represents this 2. I will bring down the 2, I will bring down the 3, I'll multiply the rest. 2 times 2 times 2 times 2, 16 times 3 is 48, and that's your LCM. So if you're still confused, please watch the video for method 2. It will help a lot. It's not my video, it's a better video, better production. Anyway, going off topic. So I'll give you a super cheat sheet, super shortcut. So you can either use method 1 or method 2. However, suppose you're finding the LCM of 4 and 7. I like to use the multiple. We'll do what do you call this? We'll use method 1. Multiples of 7 is 7. Nope. 14. 4. Does 4 go to 14? Nope. 28. Does 4 go to 28? Yes. So your LCM is 28. Now notice something. What is 28? 28 is basically 4 times 7. Why is this? Why is this LCM 4 times 7, but when you look at this, is 48 equals 16 times 24? Plug it in the calculator. No, 16 times 24 is a big number. 16 times 24 should give you guys 384. Why is this LCM different? Why is this LCM not 48 times 16, but this LCM 4 times 7, 4 times LCM 28 is 4 times 7? Why? Have you guys look at the relationship between 4 and 7, and here 16 and 24. What is the difference? What do 16 and 24 have that 4 and 7 doesn't have? Well, they have a common factor. 16 and 24 have common factors of 2, 4, I think 8 too? No, not 8. 2 and 4. So, oh no, even 8. Yeah, even 8. Yeah, they have common factors 2, 4, and 8. So, here's the thing. Where's my pen? If numbers are, what do you call that? Relatively prime, Hopefully you still remember this from the first quarter. Relatively prime LCM is number 1 times number 2 times dot dot dot. Okay, you can. Why is there dot dot dot? You might wonder. Well, sometimes I'm gonna ask you guys to find the LCM of 3 numbers. Okay, not just 2 numbers, 3 numbers. However, the same method applies. So for method 1, you're going to pick the largest of the 3, and then you're gonna see if 16 and that other number divides that the multiple. Okay, so here let's say 2. So 16, 24, and 2, find the LCM. So 24 is still the largest. 24, which I'm gonna see if 16 and 2 divides that number. 20, the first multiple of 24 is 24. Does 16 divide 24? Nope. Does 2 divide 24? Yes. So now that since 16 cannot divide 24, you move on. 48. Does 16 divide 48? Yes. Does the LCM, does 2 divide 48? Yes. So your LCM is still 8. And then same thing with method 3. So let's say it's 2 again. The stuff is right here, 2. So this group represents this 3. This group represents this group. And you can see the stuff, right? So it's still going to be 48. Okay, so if there's 3 numbers, I just want you guys to focus on method 1. Method 2 is kind of iffy. I'm already confused on method 2 with 3 numbers. So I'm hopefully don't do method 2 if you have 3 numbers or more. Anyway, moving on. Why is LCM important? Why the frick do we learn this stuff? Well, we will use LCM in fraction, that's why it's important. But instead of LCM, it's more known as LCD, least common denominator. Basically, it's the least common multiple of the denominator of 2 or more fraction. So we're going a bit more specific here. Instead of the multiple of any number, we're going to find the least common of the denominator. So why is LCM important? Well, LCM is important because it allows us to find equivalent fractions of 2 different numbers. Okay? I mean 2 different fractions. So let's have a story time comparing ordinary fraction. McDonald's has a burger called a quarter-pound burger, and A&W has a burger called a third-pounder burger. Suppose both burgers has the same price and the same taste. Which burger is the better deal? So if you don't look at the picture yet, please don't look. So if you think about it, a lot of people, many of you guys, hopefully, will think that the third pounder is bigger. However, truth of the matter is, a lot of people will probably think the quarter pound is bigger. Why? Because of this. A quarter is 4. A third is 3. 4 is bigger than 3, so that means quarter pounder is bigger than a third pounder. But that's wrong. A third is 1/3, 1 over 3. And if you write that in a fraction, it looks like this. And a quarter is 1/4. And if you write it in a fraction, it looks like this. And as you can see, 1/3 is way bigger than 1/4. But how bigger, how big is 1/3 compared to 1/4? Well, we don't know, right? How do we do that? Well, what we need to do is we need to cut them the same way. Here we're going to modify the circle such that when we cut it, they will look the same way. So bear with me. So first of all, we'll cut this one here, and right here, and right here, and right here, and right here. Sorry for my horrible handwriting. Yep, we cut it into 12 slices. Now let's cut this one into, excuse my horrible cutting skills, and a little bit Photoshop. Boom. 1/3 and 1/4. We cut it. We cut them in the same way. We cut them into 12 slices. We're going to convert them into this picture and this picture. And as you can see, it's cut into 12. So our denominator is now 12. And let's count the shaded size. 1, 2, 3, 4. This is 4/12. And this 1/4 is now 1, 2, 3, 3/12. Now you can see that 1/3 is bigger than 1/4 by this amount, and this amount is 1/12. That's how big 1/3 is compared to 1/4. Okay, I'm going a bit off topic. We're doing subtraction already, but as you can see, it's way easier. Now look at this. We have 4/12 and 3/12. When the denominators are the same, the only thing we need to compare is the numerator. It's way easier because 4/12 is bigger than 3/12. We already know this one picture, but if you look at closely, the numerator is bigger than this numerator. 4 is bigger than 3. So instead of drawing the picture, because I know I'm a horrible drawer, instead of drawing it, it's better to just convert the fraction, both fraction, so that they have the same denominator, and the only thing you need to compare is the numerator, 4 and 3. So, but how do we do that? I don't want to draw and then cut slices again. I mean, it's defeating the purpose. So we need a better way to start converting fraction so that they have the same denominator. How do we do that? Well, there's actually 3 steps. 3 easy steps. There's a Disney song about that 3 steps. I'll slow, I think. Never mind, I'm going off topic again, sorry about that. How to convert fraction to the same denominator. So first thing is, find the LCD or LCM of the denominator. Up to you. I like to say LCD better. Find the LCD, and then for each fraction, determine the number needed to multiply the denominator to get the LCD. Sounds complicated, but it's quite easy. Step 3 is multiply both the numerator and the denominator by the number you found in step 2. Again, super easy, and that's why I want you guys to use your calculator so you guys are more precise, because this is fractions. So let's do some examples. So let's compare which fraction is bigger, 2/3 or 1/6. Again, I already know that some student will automatically think, oh, it's 1/6. Why is that? because 6 is bigger than 3. Duh. However, that's the wrong way of thinking. You cannot compare them yet because, first thing first, they have different denominators. So how do we do that? We need to convert them so that they have the same denominator. Find the LCD. So here is 3 and 6. Again, I like to use method 1. Method 1 is finding the LCD. Use the largest of the denominator, in this case 6. 6 multiples of 6. So 6, does 3 go to 6? Yes. So your LCD is 6. That's all you do. Now you're going to think 2/3 and 1/6. How can we, what number do we multiply to 3 to get to 6? What number do we multiply to 3 to get to 6? 2. So we multiply the bottom to go to 6. However, since we're multiplying the bottom with 2, we also need to multiply the top with 2. Why is that? Well, if you multiply both the numerator and the denominator with the same number, you're just multiplying them by 1. Again, remember, from our fraction review, that 2/2 is basically 1. This is a fancy 1. Now let's talk about 1/6. What number do we multiply to 6 to get to 6? 1. So we also multiply the top with 1. Now multiply accordingly. 2 times 2 is 4. 2 times 3 is 6. And this is just 1/6. And as you can see, 4/6 is bigger than 1/6 because 4 is bigger than 1. So essentially, you can give me this answer already, or if you're feeling nice, you can do this. 2/3 is bigger than 1/6. I'll accept both numbers. I'll accept both answers. Okay, even though this one's the simple version, but I just want you guys to start converting. Just want to see this step though. This step is the best step. Multiplying both the numerator and the denominator with the same number to convert a fraction. This is last week's lesson. Now let's try 3/9 and 5/6. So again, find the LCD. Here's 9. Does 6 go to 9? Nope. 18. Does 6 go to 18? Yes. So your LCD is 18. Now convert. What number? 3/9 and 5/6. What number do we multiply to 9 to go to 18? 2. So we also multiply the top with 2. Now we do the same thing with the bottom. What number do we multiply to 6 to go to 18? You can use your calculator. 3. 6 times 3 is 18. Now, what number do we multiply the top with? 2? No, 3. Because we're multiplying the bottom with 3. We need to, it's like a mirror. Whatever you do in the bottom part of the fraction bar, you also do it on the top part of the fraction bar. Now convert. 2 times 3 is 6. 2 times 9 is 18. 5 times 3 is 15. 6 times 3 is 18. Now, as you can see, this is 5/18 is way bigger than 6/18. So, if you convert this, you'll get 3/9 is less than 5/6. Now, hopefully you guys are good. Any questions about comparing fractions? Now let's try you guys ordering fractions from smallest to largest. We have three fractions. You guys may be given four or five or something higher. However, the same steps applies. Find the LCD. Here we're going to use 15. Does it go 9 go to 15? Nope. 5 times 1, 5 times 2. 9 doesn't go to 5 times 3. So 15, 30. Nope. Nope. How about 45? Does 6 go 40 to 45? Yes. Does 9 go to 45? Yes. So that's it. Your LCD is 45. Now convert. 5 times 6, 7 over 9, and 4 over 15. What number do we multiply to 5? And what number do we multiply to 6 to get to 45? Use your calculators. Oh shoot, my bad. My bad. The LCD is actually 90, not 45. 6 cannot go to 45. I just remember that. So again, your LCD is 90. Now multiply the rest. 5 over 6, 7 over 9, and 4 over 15. We want to convert all the denominators to 90. So what number do we multiply to 6 to go to 90? Use your calculators. 90. So when you multiply 15 to go to 90. So we also multiply the top to go 90. Now for 9, that's pretty obvious. We multiply 10. So we multiply both the top and the bottom with 10. And for 4 over 15, we multiply 6. Now, our fraction is, this one is, obviously all of them is under 9 over 90. 5 times 15, you get 75, 70, and 24. Now arrange that from smallest to greatest. 4 over 15 is your smallest because it's 24. Next is 7 over 9 and 5 over 6. So that's your final answer. And then, any questions? You can put it in on the Google Classroom chat or whatnot. Hopefully you enjoyed the video. If you do have questions, we have meeting on Fridays for this. Anyway, hopefully you learned a lot for this lesson. I'll see you in the next video. Goodbye.